Okay. Now this is finding vector equation of a line. So in vector equation of line, this is in 3-dimensional. So when you use coordinate geometry now, you get in 2-dimensional. So if you want coordinate also in 3-dimension, you should use vectors.
Okay.
What information is necessary and sufficient to determine equation of a line? So basically you need two things. You'll need, suppose if you want to find equation of a line in 2-dimensional, what are the things you need?
The slope, the y-intercept.
Perfect. So here you need a direction vector.
Which is your OB minus OA.
Your direction vector will behave like a slope.
Okay.
Think like that.
Okay.
In 3D we call it direction vector. We don't call it slope. And you need a known point.
So isn't the direction vector the full equation of the line?
No. It's a slope. It's only the slope. It's something like slope. It's not the slope. And you need to know coordinates of a point, which in short I'll say it's a known point. Known point. Correct? So vector equation of a line is given by the formula R is equal to
A plus lambda.
Very good. How do you know that? Formula booklet. Correct. What is A?
No idea.
Okay. Now when I tell you y is equal to mx plus c, what is x and y?
X and y coordinates of the random point.
Okay. So similarly R is the coordinates of any random point. It's
Just
a position vector. Okay. So that's your position vector x, y, z.
Okay.
It's a position vector of any random point on the line.
Okay, on the line. Okay. Fine.
On the line. See, remember where we are now restricting ourselves to the line.
Yeah.
It's exactly like that.
Okay.
What is your A?
Your direction vector.
Known point.
Oh, no. But so isn't the known point the same as your?
And your B is your direction vector.
But so isn't your known point? Oh, your known point in your
like
and your known point in your R can't be the same.
Known point. Two different.
Okay. What's lambda?
Lambda is your parameter. Now what is parameter? We'll discuss in few seconds from now. Parameter is a variable. You leave it as a variable.
Okay.
And then this is a direction vector. So basically this thing you need to remember. You need to get the direction vector and the known. Consider vector passing through A 211 and B 403. Find a direction vector for the line.
OA minus OB minus OA.
So direction vector would be what? OB minus OA.
Yeah.
Now for line it doesn't matter. You can also take OA minus OB. It won't matter.
Okay.
But you don't change anything. So 403. So your coordinates become the position vector minus 211.
Which is equal to 2 minus 1.
Perfect. So vector equation of a line. R is equal to what? A plus lambda B. So R you leave it as R. What's your A?
A is 2 minus 1.
No.
Oh, that's B. Sorry.
Any
known
point. Either you take A or you can take B. But a position vector. So 2, 1, 1.
Okay.
Plus lambda times your direction vector.
Which is 2 minus 1. Okay. But so then can't you take your R as say 403?
So then you get it from. Now what's going to happen is, so what is happening is, this is the vector equation like in 3 dimensions. When your lambda is 0, what will your R be?
2, 1, 1.
So when your lambda is 0, it corresponds to 2, 1, 1. So that's your point A.
Okay.
Now if you take lambda as 1, what will you get?
You will get 0,
4,
minus
4,
0.
No, 4, no? If you take lambda as 1.
0, 0, 3, no?
If you take lambda as 1, if you put lambda as 1,
okay, that now. Okay,
4, 0, 3.
3.
So when you put this as 1, you will get 403.
Okay.
It will correspond to some other point of the line.
Okay. Oh, the same line. Okay.
So every coordinate will have a corresponding lambda. Every coordinate will. So if you have lambda as a fraction, you will get coordinates of point in between.
Okay.
So every lambda corresponds to coordinates.
Okay.
So your R is your general point x, y, z.
Got it.
So if you fix your lambda, your coordinates. No period. It's any variable. It's any real number.
Okay.
So when you substitute the value of lambda,
can it be negative numbers?
Yeah, it can be negative. So negative points will map here.
Got it. Like that.
Positive will map here. Now suppose if you take B as here, 403, then lambda correspond to B will be 0.
Meaning?
If I take 403, when I take lambda is 0,
it'll just be 403.
So that means your B will become 403.
Oh, like that. No, your R will become 403. So if your lambda is 0,
see, suppose if I take R is equal to 403, suppose somebody does like this, plus mu, let's say 2 minus 1, 2.
So
now
R over here, oh, your lambda 0 is 403.
Yeah.
Okay, that's what we write.
So that means yeah. So what is going to happen is now your lambda is equal to 0 will start from 403. And this will be lambda or mu. I am calling it mu because it's not the same thing. And here your mu will become minus 1. So when you put mu as minus 1, you will get your point 8. So that lambda is called the parameter, mu is called the parameter. Okay?
Yes.
Now what you need to remember is the following. What are the two ways in which the equation of this line can be written? There are two other ways.
So this
is a vector form. This vector form.
So it's like slope only. Like
like that only. Now suppose if you put your r as x, y, z, so x is equal to 2 plus 2 lambda. Y will be 1 minus lambda. Correct now? So I'm calling this x, y, z. So I'm doing ijk basically. I'm just doing this.
Yeah.
I'm just doing this.
Oh, so you write them as
and z is equal to 3 different equations.
X minus x
1 plus 2 lambda. This is called the parametric form. It's called the parametric form. I think so. It's there in a formula book.
Yeah. No, but it's
same thing. X, Y, Z.
X0 is the same as
X0. So they have done what you know in your formula.
So it's basically
X0, Y0, Z0 plus lambda times LMN.
Got it. I understand.
So then X plus N. Basically you split it up here. Right? Parametric form. So there's nothing great about parametric form. It's just derived from this. This is the main form. The vector equation. Vector equation is the main thing.
Vector. Okay.
That's the main thing. Okay. Now, if you want to make it Cartesian form, so what you do is
Cartesian is like a regular slope.
X, Y, Z in terms of X, Y, Z. You don't want any lambda coming in the picture. So get rid of lambda. So in equation 1, if you make lambda the subject, what will it be?
It will be R
x minus 2 upon minus 2.
Wait, which equation?
Equation 1.
Okay, sorry. X minus 2 divided by 2.
In this equation 1, make lambda the subject.
Divided by positive 2. So by negative 2.
And divide by positive 2. Yes, my mistake. Okay. Now in y, make lambda the subject.
So it will just be 1 minus y.
Can I do y minus 1 upon minus 1?
Yeah.
Just I'll tell you for a specific reason. Is equal to?
This will be z minus 1 divided by 2.
This is called the Cartesian form.
So you know all your lambdas have to be the same, which is why you just equate.
Correct.
All the lambda equations.
Correct. Cartesian form. Now if you observe Cartesian form closely, now look at your formula booklet.
X minus x over L, y minus y over L.
What is this?
X over y. So whatever we've taken as our A, basically.
That's correct. That's your point. So this is your point. And what is this?
That is your R.
Direction vector.
Oh, sorry. Oh, that's the direction. Okay.
But if you write this as 1 minus y, then this won't be direction vector. So you have to write y minus. So variables have to come in front. X,
always.
Y, Z. Then this will be your direction vector, and this will be your position vector for known point. But you may not go into all those details. You simply get this first automatically, and you will.
So you basically just always want to whenever you're converting.
Get a vector form. Get the vector form.
Okay.
Bas, everything is done.
Got it.
Then you can just look at this and write everything.
Yeah, that's true.
Here, now they've given you this. So suppose that x, y, z is equal to a1, a2, a3 plus t times
so
b1, b2, b3.
X is equal to 8
this line can also be parametric form. Yeah.
X is equal to a1 plus pv1, y is equal to a2 plus pv2
A2
Z is equal
plus
to
TB2.
Z is equal to A3 plus TB3.
Perfect. Cartesian form.
X minus A divided by B1 is equal to Y minus A2 divided by B2 is equal to Z minus A3 over B3.
That's a nutshell. End of the story. Okay. Find the parametric and Cartesian equations for the line through 1, minus 2, 3 and the direction vectors 4i plus 5. R is equal to A plus lambda B. What's your A?
My A is
The known point.
O, which is 1.
The position vector of the known point. This is this plus lambda times this is your direction vector. That you mixed up.
Conceptually.
Find out so parametric equation.
X is equal
to 1 plus 4 lambda. Y is equal to minus
2 plus 5 lambda. That is equal to 3 plus 3 minus 6 lambda.
Okay, Cartesian form.
X minus 1 divided by 4 is equal to y plus 2 divided by 5 is equal to z minus 3 divided by minus 6.
Yeah, Cartesian. That's it. End of the story.
Easy.
Very simple.
Yeah.
Okay, next.
Y is equal to 5. Okay. Where's the y come from? There's no y anywhere.
So y is equal to 5 is a constant point, it's a steady point on the line.
Okay.
Y is always 5, doesn't depend on the parameter.
So where's y in the...
So now what will you do?
So
parametric
form.
So what will your x be? So now what you do is equal to z minus 4 upon minus 4. You call it lambda.
Okay.
So your x will be what? X minus 1 over 2 is equal to lambda.
Yeah.
So x is equal to 2 lambda plus 1.
Right.
Z minus 4 upon minus 4 is equal to lambda. So z is equal to 4 minus 4 lambda.
Right.
So your y will be equal to 5. This is your parametric form.
Oh.
Your y doesn't depend on the parameter.
Good. Okay.
Y
is always 5.
Y is always 5, no matter what the parameter. It's a constant number basically. Okay. And name the direction vector for this line. What is the direction vector for this line?
OA minus OB minus OC.
The coefficient of, write all the coefficients of lambda.
Okay. Coefficient of lambda direction.
So R is equal to A plus lambda B. Yeah, B is your direction vector.
Which is your coefficient of lambda. So 2, 5, 4.
No, 2, 0, minus 4. Because there's 0 lambda. No? This means there's no lambda only.
This is 5. Yeah.
Okay. True or false? The angle between two lines is the angle between the direction vectors?
Yeah.
Yeah, obviously true. That's what you need to remember. If you are finding angle between two lines,
between two vectors.
Now, how do you find angle between two
vectors? The cos thing is
correct. Cos theta. Correct. Very good. Find a acute angle between these two lines. Now this is in 2 dimensional basically.
Using this dot.
So now what form is given?
So this is.
Or can you get a direction vector of the first line?
Of the first line, yes sir. No? The direction vector would be -3, 1.
What is the direction vector of the second line?
2, 3.
Now use your formula. Cos theta is equal to x1. What do they call it? A1. They calling it V1. V1 W1 plus V2 W2 divided by V1 square plus V2 square. Correct? Means the magnitude of these vectors basically.
Correct.
So that's -3 into 2 plus 1 into 3 divided by root of 9 plus 1 and root of 4 plus 9. So -6
plus 3.
Now if you want an acute angle, you put this in modulus. Because acute angle also you take ups.
Okay.
All are positive, no? So you upon root 10, root 13 modulus of that. So theta is equal to cos inverse of 3 upon root 130. Because modulus means I'm just removing the minus sign.
Degrees also?
Yeah, degrees.
74.7.
74.7? Yeah. Okay, if you put the minus sign, what will you get? You will get 180 minus that.
Okay.
So that means later on you can do 180 minus.
Correct. You want to
Yeah,
do
yeah.
angle, so you get
So basically, because when you have two lines, one angle will be obtuse and one angle will be acute. It depends on what you look at. Like suppose if you look at this angle, that was obtuse, and this is the acute angle between two. So if you don't remove the minus sign, you will get this angle. But you want the acute angle, so you can later on do 180 minus that.
Understood.
Or else if you put a modulus, then you don't have to do that.
Understood, sir.
Okay.
So
This is
what is it? What is it? R means?
no, just ignore this.
Okay. So I have to equate both the equations.
Correct. Equate both.
Vector forms.
So these are directly the vector form. So if I equate it, what will I get? Minus 1 plus 3 lambda is equal to what?
4
Plus 2
mu.
Second equation?
4 minus 2 lambda is equal to 4 minus 3 mu.
4 minus 3 mu.
And lambda is equal to
Lambda.
minus 1 plus 2 mu.
Correct. Now you take any two equations. I'll take 1 and 2. You can take any two also. I'm taking first two.
Okay.
And solving it simultaneously to find lambda and mu.
Okay.
So what will happen is 3 lambda minus 2 mu is equal to 5.
Okay.
And this is minus 2 lambda plus 3 mu 0. Now solve it simultaneously. You will get your lambda and you will get your mu. Now check whether it satisfies the third equation. Always. Check.
3 is equal to minus
So 3 is
1.
equal to minus 1 plus 2 into 2. Yes. When the lines are intersecting. If it doesn't satisfy the third equation, then the lines are skew.
Meaning?
Skew lines means you can think like in 3 dimensions. Suppose if I get a cuboid, if I give you a cuboid in 3 dimensions, you have one line like this, correct? And other line, let's say running like a diagonal, but not intersecting this, not necessarily parallel, but no, it's like I don't know how to explain it. The lines will neither be parallel nor be intersecting like this. If I give you like this,
So they intersect somewhere.
no, they won't. Suppose if I give you one line like this and one like this.
Oh.
So from here you think it's intersecting.
Yeah,
but they are at a different height. They're like two flights which are there.
Yeah.
So if your two flights are going, you give them different height.
Yeah, so nothing will happen.
They won't crash because the heights are different. They're going in different directions, but the heights are not the same.
They're flying over the same point, but at different heights.
They're flying at the same point but different heights.
Got it.
So checking this will avoid them being skew lines. Skew. So sometimes that will come in the next.
Skew means statistics.
Not that skew. Yeah, that's a different skew.
Okay.
So what is the point of intersection be now?
The point of
You put lambda in the first equation, or you put mu in the second equation.
Okay.
So you will get your x.
So your R is your point of intersection basically. R and S is your point of
Because you
intersection.
equated them. You equated them. You're asking them, okay, for which points are they equal? 4 minus 3 2s are 6, correct? And 0 plus 3. So that is equal to 8, correct? Minus 2, 3. So that means my point of intersection is 8 minus 2, 3. Achha, even if you put mu, you will get the same answer.
Okay, so you substitute one or the other basically.
You have to get the same answer because you equated them more than.
Got it. For angle, you just use the same formula, cos formula.
But what? To what?
So any two equations. No?
Any two
Vectors.
So which vectors?
So you use position vectors, no?
No, direction vectors. Don't forget.
Oh. Why would you use position vectors here?
Position vectors for a point.
But so isn't V and W just any 2 points?
Don't confuse the two concepts. If you are looking at that, there are also two vectors only, they are not points.
Oh.
So for two lines, you have to take the direction vectors. If you want to find angle between two lines,
Yes.
see, that's what we said now. You said 2 over here. The angle between two lines is the angle between the direction vectors.
Oh my God.
This is the concept we are applying. So if I give you two lines ka equation, you find the direction vectors and get the angle between them. Direction vector is the coefficient of the parameter. So this is my direction vector of the first one. What is my direction vector of the second one?
2 minus 3, 2.
So your cos theta is equal to 3 into 2, correct?
Yeah.
Plus minus 2 into minus 3 plus 1 into 2 divided by root of 9 plus 4 plus 1, correct? Root of 4 plus 9 plus 4. Correct? That's how much?
That's 6.
Theta is equal to cos inverse.
Plus 3, so that's 15 divided
6
by.
plus 6, 12. 12. Correct? 12 plus 4 is 14.
12 plus 2, right?
12 plus 2 is 14. No?
Oh, it's 2, my bad. 14. My bad.
14 divided by
So root of 13 times root of
17. Correct? So get that. 19.7 degrees. Is the angle between these two lines. So two things. Point of intersection. For point of intersection, you equate.
Okay.
For point of intersection, you equate the two lines. And for the angle, you find the angle between the direction vectors.
Got it. Okay.
Now, another thing you need to remember is your position of any moving particle is the initial position, you can call it anything you like, initial position plus t times the velocity vector, where t is the time, v is the velocity vector. It's like your r is equal to a plus lambda b only. This is the initial position. And what is p? Position at any time t. Position.
So same formula basically.
Same formula basically, but the interpretation changes at time t. So position at any time t is equal to initial position, is not the acceleration. Okay. Initial position.
So your velocity vector is like a slope.
Your velocity vector is like a slope.
Okay. And your time is
now,
obviously your x.
How do you find the speed when the velocity vector is?
Absolute value of the.
Perfect. So your speed is the magnitude of the velocity vector. So speed of the first vehicle is the magnitude of the velocity vector. Tell me what is the magnitude of the first.
So it will be
flight.
Root of 3 plus.
Root of 3 square 9 minus 2 square 4 plus 1. Are you following that? You are taking this. You are taking the velocity vector and finding its magnitude. So that's how much root of
40.
And what is the speed of the second flight?
That will be root of 4 plus 9 plus 2, which is root of 50.
4 plus 9 plus 4. This is how much? 17. Correct?
Yeah.
So therefore, which fly is flying faster? The second one. Second one is faster. This is without calculator. With calculator also it comes and you can just get the decimal.
You use the same thing on the calculator also.
Root 14 you will do, so you write the decimal.
Okay.
Acha, do the two flies collide? If so, where and when?
They won't collide, that's all.
How do you know? You have to show it mathematically. So you find a point of intersection.
Okay.
If they are colliding, then you have to find a point of intersection. Now, if you are finding the point of intersection, what are you planning to do? What will you do for point of intersection? You equate them. Okay. So what is my first equation? Minus 1 plus
minus 1 plus
3t. Now 3t1, I'll call it t1 because it's for the first flight. Is equal to 4 plus 2t2. Correct?
And then
4 minus 2t1 because of the first flight, the time of flight for the first flight.
is
Now
equal
we don't know whether they started flying in the same time or
to
not. So we don't know
equal
that.
to 4 minus 3t.
Next one. 0
0
plus t1
is equal to minus 1 plus 2t2. But you can take any two now, sir.
Any two. I'll take first two. So that means 3t1 minus 2t2 is equal to 5. And this is minus 2t1 plus 3t2 is equal to 0. So you solve this simultaneously.
3 and 2.
It's the same sum, I think so. Only one. So t1 is 3 and t2 is 2. Now see whether it satisfies the third one. 3 is equal to minus 1 plus 4. Yes.
So they won't collide.
No,
Oh,
yes, they will collide. Means they'll be at a common point at this time. So the flies will collide.
Now when will they collide?
The flies will collide. Where will they collide? Where? When will they collide? When t1 is equal to when the time of flight for the first fly is 3 whatever second time, whatever units, and t2 is 2 units. Means
yeah, when t1 3, t2 has to be 2 basically.
So t1, so the first fly has been longer in the flight compared to the second one.
Correct.
Basically. And where will they collide? You substitute that. So your x, y, z. Where is their coordinates? So if I put 3 in the first one, what will it be? Minus 1 plus 9. I'm putting it here.
Where? Okay.
I'm putting it here.
Okay.
So I'm putting 3 over here. Correct? And 4 minus 6. 3 I'm putting it then. For the first one I'll put 3.
And then 0 plus 3.
So that's what? 8
minus 2, 3.
See, either you put this in the first one
or you put the second one,
or this in the second one, you'll get the same answer.
Okay. It'll give you
Because that's a common point basically. That's why they collide.
Understood.
Compare question 7b and 6a.
Same thing. We just said the
Unless they wanted it not to collide. I don't know whether we made any mistake or not. 5 minus 2 plus 3 2 is equal to 0. Enter it correctly. Unless they don't collide. 3 minus 2, 5. Yeah, so you're right. So basically, if the third equation was satisfied,
then it means it hasn't collided.
Yeah, they don't collide basically. That's a skew thing. In question 7, what is each fly's initial position? What is the first fly's initial position?
Minus 140.
Minus 140. This is the initial position. What is each fly's first fly initial position? And for the second one is just to explain the concept. 4 4 minus 1. Each fly's velocity vector. This is the first fly's velocity vector. This is second fly's velocity.
3 minus 2 1.
2 minus 3 2. Correct. Each fly speed we found out now. We found that. This is just to reiterate.
So we just say it as minus 14 minus 17.
Yeah. Speed is root of 14 and root of 17. Next. How many questions are there? Long. Doesn't matter. Says one of each type basically.
Yeah.
Now, a ship leaves a port traveling in this direction at a speed of 10 kilometers per hour.
Okay.
Now, if you know the direction, and if you know the speed, how will you find the velocity vector? You need the velocity vector, no? Because position is equal to initial position, or you can call it T naught if you want. Initial position plus TV.
The absolute value of that is 10.
The absolute value of the vector is 10.
Correct.
So what's your vector?
So we have a T.
Now you need to remember this. Velocity vector is equal to speed into the unit direction vector.
What is that?
Unit direction vector. You remember how to find a unit vector?
Yes, sir.
What do you do? So speed is 10.
Yeah. OB minus OA is your unit.
And your unit direction vectors you divide by the magnitude. You remember that? 9 plus 16.
What?
Arey Baba, if this is your direction
Oh,
vector,
yeah, okay, this right
your
here,
unit
this
direction vector is root
Yeah,
of this square plus this
Magnitude
square.
times
Magnitude of that.
Correct.
You take the magnitude of direction vector.
I multiplied by it. Yeah. Got it.
Correct. So this is 10 upon 5. Correct. 3, 4. 5 twos are. So that's 6, 8. So my velocity vector is what?
Sorry?
Speed into unit direction vector. So that's your velocity vector, 6, 8. So that means what is my find the position of the ship as a function of time. So P is equal to, what's my initial position?
3, 4. Oh, wait, no.
It starts from the port.
Minus
8, 3. It starts from the port.
No.
Plus any time. This is the time which.
And your velocity
Time
is
of
6,
travel.
8. Correct.
Time of travel.
Time from leaving. 6, 8.
6.
Okay.
So basically when time is 0, it's at the port.
Got it, yeah. And T minutes after, T whatever after.
So 1 hour after,
leaving,
it will show the position at that point. 2 times after, it will show the position at that point.
So it's a function basically.
It's a function basically of time.
Okay.
Use your calculator in parametric mode to graph to show the motion of the ship. Okay. So now, parametric equation, x is equal to what?
Minus 8 plus 6t, y is equal to 3 plus 8t.
So you go to graphs, go to parametric, type, delete all this, which is not required. Type parametric equation, type in minus 8 plus 60, correct? And your y is equal to 3 plus 8t. Now this can calculate.
So would you take a t as something given?
No, variable. No. That's what the parametric thing. They calculate as the capacity to graph this.
3 plus
Now view window,
8.
standard. So zoom out.
I see.
Zoom out. If you can't see anything, zoom out. Now listen. Now what you do is trace. So when t is equal to 0, what's the position?
6, 8.
You can see the position. Yeah.
Oh, sorry, minus
That's
8,
your
Minus
velocity.
8, 3 is my position.
How do you see the position?
So it's given over here.
It's given over there as a coordinate, a small coordinate. One second, I'll zoom in further. Actually, sorry, I'll have to zoom in further. Okay, so I'll be able to see it now. Zoom in further. Okay, yeah. So trace. So t is equal to 0, so that you can see the minus 8, 3. Now t is equal to 3.6. It's going randomly. Now what you can do is you can set this how the t increases. So you can go to setup.
Oh.
Coordinates on, axis label on. No, not here. Okay, there's a something is there. You can change the value of t. I don't remember.
No.
No. Okay, nevertheless, you can also do this. Listen.
So is it this?
Scale, correct. So setup, view window. Now, you know, x dot, no, this 0.5 is given, no, you take that x dot as 1. Scale is 1. Dot is 1. Y can be, yeah, maximum 360. Pitch, go down to pitch. PTCH, make it 1.
Oh, 1.
Means it will show every 1 hour. Okay, now it will come. So view window. I change the view window unnecessarily. So minus 10 to, let's say minus 10 to 10. Okay, yeah.
Minus 10 times too small.
Yeah, fine. That's fine. I zoomed in. Now see, now you do trace.
Oh, yeah.
So now the pitch is 1. So this is,
pitch.
so see, pitch is 1. See. So after 1 hour it will be minus 2, 11.
Yeah, then for 90.
Then it goes on and on. Yeah, it goes on and on. You'll be able to see it.
Works.
Okay. So use your point to estimate when and where the ship will be closest to the second port at 10,2. So what you can do is you can change the pitch. Setup. Now you'll have to do by hand actually.
Okay. What do you change it?
You have to do by hand. You can change the pitch. Where did you do it? Setup now. View window we did it. Now. View window. This pitch. Which is, let's say 0.1. Suppose you make it. Correct. So what will happen is, and where's your point now? I'm just trying to. Where my calculator is view window. I'll take my scale as, let's say, minus 10 to 15. What is the point I've given you? 10,2. Acha, 10,2 is down. Minus 10, 10. 10,2. So I'll take it as 15. Correct? Y scale. What is the Y ka minimum value we had? Where did it start with 3? No? So you can start with 0 and 2 means 0, and this can be around 5. Yeah. So I'm just trying to get all the points and get a clearer picture. Oh.
We all know.
So where's your minus 10,2? Sorry, 10,2. 10,2 is here somewhere, isn't it?
So you can't G-solve?
No, G-solve what will you do? So where will be closest? Now the closest distance will be the perpendicular distance basically. So what is happening is, you have a line like this. This is your point 10,2. This is where it started from. This is the equation of the route that the ship will take. The closest distance will be the perpendicular distance. But now on a calculator is very difficult to see that.
Can you tell us?
No, nothing. All that. Don't waste your time on calculator, please.
Okay.
Don't waste your time over there. I mean, you have to do it, but you don't. You'll have to do it analytically.
So how would I do this manually?
That's the main thing. That's what you have to learn. That's the most important point. Not using calculator, you won't get it. Now, what you need to do is, which is the first port? Let's call the first port as Q, P. This is Q. What are the coordinates of this point?
Which one?
Point N.
What would it be, sir?
X comma Y. What's my X? Minus 8 plus 60. Get the parametric form. X is equal to minus 8 plus 60. What will Y be?
3 plus 8.
Correct. Maybe you have to find out what time this will be. This is at N. This is T when the point is at N.
Correct.
Now, can I say that Qn is perpendicular to the direction vector? Qn is perpendicular because closest point is the perpendicular.
Yeah.
What is the direction vector along this? Along the path? 6, 8.
Okay, yeah. Yeah, that remains the same. Correct.
6, 8, which is velocity vector, or if you want direction vector, they have given the direction vector, in this case 3, 4.
Yeah.
You can either take, because the ratio is the same, na? It's like a slope.
Yeah, slope.
So slope, if you write 1/2 or 2/4 is a slope. Yeah, it's like that. For direction vector, not for velocity, you can't reduce it. For direction, you can reduce it. Now, what is the condition for perpendicular vector? When are two vectors said to be perpendicular?
When the dot product is 0.
Very good. So dot product is 0. So which dot product of which two vectors now we are looking at?
Of P and Q.
Qn. So what's your Qn?
That will be 0.
What's your Qn? How do you find
ON minus OQ.
ON minus OQ? What's your ON?
O is
minus 8 plus 60
plus 3
minus OQ, which is 10 2. So what is this?
Minus 18 plus 60.
So 60 minus 18, yeah, and 80 plus 1. Now we take the dot product as equal to 0. So Qn dot D is equal to 0. So 60 minus 18, correct? And 80 plus 1 dot 34 is equal to 0. So what will this be? 3 into 60 minus 18 plus 4 into 80 plus 1, 0. 6 3s are 18, 18 3s are 54, 8 4s 32, 4 is equal to 0. So that's how much? 50.
50t
50t is equal to minus 50
plus 50.
plus 50, yeah, because it will go on the other side. So basically at 1 it is the closest to that point, at 1 hour. And what is the position at 1 hour?
So we can find so
Yeah, you can put
minus 8 plus 6 comma 3 plus 8. So it will basically be minus 2 comma 11.
Minus 2 comma 11. That was the closest. Because then it will let us. So basically what is happening is this is like this, na? I don't know why this happens even. Alright. So this is like this. So if you take t is 0, it starts here, t is 1, it starts here, t is 2, t is 3, t is 4, correct? And this point is here. So this is the closest distance. Then the distance will keep on increasing.
Okay.
Perpendicular distance is the shortest distance. They won't ask you to do it by calculator. It's just because it's your school worksheet they're asking you. Part 4. So how do you know the lines intersect?
Same dv they intersect.
You will solve equation 1 and 2,
okay,
and should satisfy the third equation, the parameters.
Okay. Okay.
You find lambda and mu, solving 1 and 2, you find lambda and mu, you plug in a third one and should satisfy it.
Okay.
Then skew lines, you solve 1 and 2.
If they
don't satisfy the third one, here this will satisfy the third equation. Parallel,
if they are the same dv.
Same direction vector, or the direction vector of one is a scalar multiple of the direction vector of the other. Like example 2, 1, 4 and 8, 4, 16.
Times 4, is 4, is 4.
That's a scalar multiple of each other.
Okay.
Coincident.
What is coincident?
Coincident, you have one line and top of that you have the other line. Coincident.
Same dv, no possible same scalar.
Means they have the same point and the same direction.
Same equation basically.
Yeah, same equation, same point and same direction.
Okay. So if the same a and same b.
Yeah.
Okay. Got
it. If two ships are traveling on a coincident path, will they collide?
What's the speed, so?
What's the speed? What time did they start?
Yeah.
Like trains, no? Local rail.
They all go on the same track.
They go on the same track, but the timings are different.
And the speed.
Start time is different.
Speed actually may be the same.
Speed may be the same, but the times are different.
Yeah.
The time elapsed from the start. Yeah, different.
They started different time.
Yeah. So paths may be coincident. Was it? Okay. Sure. Do this.
Line.
Yeah. So they're skew lines basically. No, this is 0. You entered the value wrong. This is minus 2 and 1. So 3 minus 2 into minus 2 plus 4 plus 3 into 1.
Yeah.
So 7 is equal to 7. So yeah, they do intersect.
And so you copied from me?
No, I didn't. I put 0. I looked at. No, I didn't. I didn't check your calculator entry, no?
Wait, how did you get the same answer? Me then?
Then I copied your answer from the calculator. I looked at your calculator, but I didn't know you're taking the wrong way.
Yeah, I wrote the question wrong.
No, this is 0.
No, not that. So the reason that becomes 0 is because I've taken my equation over here as minus 1 minus 10 plus
so you
1.
made a sign error.
Yeah.
Show that 1 and 3 are skew.
To show that the skew, you have to have some sort of factor.
1 and 3. So you have to solve 1 and 3 now.
Same thing.
Minus 1 plus 2s is equal to 1 plus 2u. And 1 minus 2s. So you substitute 4 into 1.
That's minus 1 and minus
4 plus 3 into 0, correct? So 5 is equal to 4. So it doesn't intersect the first cube. If I take these two and solve it, 1 and 2,
I keep getting silent.